this up. Live now. And just open this up. Okay, it's working. ያ የዛሬው በጣም የአክቹዋሊ የተፈጠረው ማይ ፎን ስልኬ ቻርጅ አልነበረውም ማታ ከዛ አላርሙ ሞልቼ ተኛውኝ and it didn't wake me up, so yeah, so I didn't wake up, so we are like 2 ሰዓት ነው የሚከፈተው ለዚህ 2 ሰዓት ከ48 ደቂቃ we are late, so we're gonna use Elm today. ችግሩ ኤልም ላይ it's a browser only, like it compiles to JavaScript and that JavaScript can only run in your browser. It's not like ባለፈው I think Gleamim, one of the languages that supports compiling to JavaScript, is one of them. Again, በግሊም case you can compile it to like JavaScript code that could run on Node.js ምናምን ነገር. Elm again, it's a UI only, it's a front end only functional programming it's a UI only for functional programming language, so yeah. Oh, nice. Thanks. Okay, thanks for being here. So okay, so let's get started now. Problem number. Okay, I'm gonna drink some water first again. Hopefully they'll give us an easy one because it's a Sunday. It's not in the view yet. Okay. So day 7 laboratories. You thank the cephalopods for the help and exit the tranche compactor, finding yourself in the familiar halls of a Northport research ring. Based on the large signs that says teleporter hub, they seem to be researching teleportation. You can't help but try it for yourself and step onto the large arrow teleporter pod. Okay, suddenly you find yourself in an unfamiliar room. The room has no doors. The only way out is the teleporter. Unfortunately, the teleporter seems to be leaking magic smoke. Okay, since this is a teleporter lab, there are lots of spare parts, manuals, and diagnostic equipment laying around. After connecting one of the diagnostic tools, it helpfully displays error code 0H-N0, which apparently means that there is an issue with one of the tachyon manifolds. You quickly locate a diagram of the tachyon manifold. Your puzzle inputs a tachyon beam enters the manifold at the location marked S. And tachyon beams always move downward. Tachyon beams pass freely through empty space. However, if a tachyon beam encounters a splitter, which is that the beam is stopped. Instead, a new tachyon beam continues from the immediate left and from the immediate right of the splitter. Okay, wow. The visualizations, if you guys have checked out the Advent of Code Reddit, people create visualizers for each one of the parsers. So this the visualizers for this one are gonna be cool. Okay, so for example, let's look at this. It starts as S, and then there is, okay, it looks like a Christmas tree. So okay, in this example, the incoming tachyon beam, okay, extends downward at the point where the original beam stops. 2 new beams are emitted from the splitter, okay, like immediately to the left and immediately to the right. Those beams continue downward until they reach more splitters. Okay, at some point these 2 splitters create a total only at this point the 2 splitters create a total of only 3 tachyon beams, since they are both dumping tachyons into the same place between the beam. Okay, This process continues until all of the tachyon beams reach a splitter or exit the manifold. This process continues until all the tachyon beams reach the splitter, reach a splitter or okay, exit the manifold. To repair the teleporter, you first need to understand the beam splitting properties of the tachyon. In this example, a tachyon beam is split a total of 21 times. Okay, so do we count the لمثال الذكاء alone with did they count just the lines? How many times will the beam split? Okay. I guess what? The number of times it's split is gonna be the count of this 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, I guess some of this would be I thought it didn't split to 21 times. Which ones are supposed to be counted? To repair the teleporter, you first need to understand the beam splitting properties of the tachyon manifold. In this example, a tachyon beam is split a total of 21 times. So these steps, they're talking about these steps, like these steps happened 21 times. Or it took us like 20 iterations of the loop to get them all to their end positions. Now it's not just the count of the split positions, because there are many split positions. It's not a count of the splitters. There are many more splitters. It's a count of how many steps it took to get them. Could there be steps where we don't split? For example, this one, I think this step would I don't know what our structure. So I don't know if we're gonna pass this. I'm not even think. I don't even know what kind of structure would be good to represent this thing. We just need to do another two-dimensional grid, right? So yeah, I don't even think we should parse it to another structure. It's not gonna help us in any way. Yeah, it's not gonna help us. So we're just gonna implement a loop that will just take an input and then move them down like a step function, and then call it and then we need another function to be able to know the current state of the if we're at the final state, and then we will loop over. Okay. Yeah, it's a UI programming language. What I meant with browser only is, maybe they mention it here. They have this thing called the Elm architecture, and yeah, it's a browser program. Okay, let's do it. Let's create the directory day 7. And then Elm. Let's do part 1 first. Make there part 1, and then let's go into part 1. Elm init. Yes. Okay, see, there is a source, and then it has nothing. Let's create a text source, and then let's call it part 1 dot elm module part one exposing everything. I guess everything is just 3 dots. And I guess we need to, since this language server takes a while, we need to do something like this. And then there is some boilerplate I need to paste in so that we can see something on our, it's gonna compile to an HTML page now, so we're gonna need, let's go into here, and then let's go into, they have a section on SPAs, or where you define an application. I think it's part of the JSON parsing or module structure. Yeah, something. Okay, I think it's in the web app section. And then we create a document instead. Didn't I have a full example here? Yep, this is what we wanted. But we don't really care about the, okay, we can convert it to a document. Copy this. This is way too far, it should be right next to this. And then let's open it up again. Import URL, don't care about the URL. Let's make this a browser.document. And now we don't receive these things, I think, if we do that. Yeah, so it only receives it only needs to export an update subscription. Yeah, and then we can remove this. Our model is gonna be empty. This is okay. We're not gonna receive any messages for now. Let's do a no op, and we can there are field patterns. So let's do a no op, and then it can return this command dot none. Yeah, Elm architecture boilerplate, because we're gonna be using it. This all of this stuff is meant to be used for building web apps, and since we're just gonna give it some input and just have it render our solution on the page, we are not gonna care about those. So it's just, I guess we need the view function, and that should be simpler. Let's remove those. Let's say hello, and then let's do advent of code die of 7 to that. Oh, I just remembered that I didn't install Elm format, but I think the language server will format it for us, if I remember. So that's not required. No. Let's do subscriptions. Yes, we can return. Okay. No. Copy. It's complaining that it couldn't find the subscription, so let's just that separator there, and then subscriptions. Okay, why did this error? Type mismatch. Type mismatch in the init function. The body is a tuple of the type command message, but the type annotation of init says it should be. But I've updated that. Let's run Elm reactor. Let's go here and open it up here. Source main. It will show us the error here, I think. Oh, okay. It's saying it shouldn't be a function. Okay. It's a flags comma. Okay, flags. Oh no. What are flags though? Do we have to define the flags? And then I think we define the flags here, and our flags are currently this. So I don't know what it's complaining about. Ignore that. We can. What if we remove the type annotation? It's double empty. Let's go to, I guess, there is another Elm browser document. There is another, just another tutorial. Yeah, this is the page. Beginning Elm. I think they describe it correctly. The difference between each one of them. How can I? Maybe I have to tell it the. So elmprogram.com browser.document. Oh, okay. Wow, okay, I know what's wrong. So it should be like this, but we're not. We should be doing that. Yeah, okay. So now Halo is being rendered here. Let's instead do an H1, and I think if we, and I guess this will be empty, and I know this will be H1, no attributes, and the body is gonna be this text. And I think Elm reactor will automatically format. No, I think compile our code. I guess we have to do a refresh. But yeah. Okay, so now we have all the boilerplate set up. Delete report ban. Okay. Let's go back to our puzzle. So we're just gonna need to create a function that's gonna take at least the thing that we have more operations over a list. So I think I'm just gonna convert them into a list first. So that's what I'm gonna do. And then the other weird part about Elm is, like I said, since it's a browser, it's a browser only language, there is no way we can't really read a file. So in the previous examples we were using what were we using? We were reading normal text files, and then we were reading them via each programming language we are using. But now we can't really do that. So what we need to do is I'm gonna define a module for the input one, and then just import it as a variable. So input one exposing input, and then input equals this, right? And then this should be this. Okay, so we're just gonna do that elm multi-line string. Oh, okay. So we just need to do this 3 consecutive quotes, and at the end 3 consecutive quotes, so that we don't get that extra new line there. And let's go here, and I guess we can move this up. Okay, so input 1, I need to match I require the module names correspond to the file path. Okay, I'm just gonna do that then. The language server for this, for the Elm language server is actually, I don't know, it really takes its time when it's quitting, when I'm closing the editor, so that's gonna be annoying. So let's rename. I think we should just keep one editor open at all times. So we have our input there. Then I'm gonna remove this one. Oh no, okay, we need to ignore Elm stuff and input 1.elm, because they don't want us to put our inputs on GitHub and stuff. You don't have to share. I guess you can't share your inputs to publicly. I think that if they've said that. So let's do this, and then let's open this up again, part 1. Let's close this. So here we can import our input 1, exposing the input, right? We can even see it, we can even render it if we wanted to here. Oh, it's not part of our model, but we can do it. Input. Oh, so okay. This should be h1 body. What else are we using? And then I guess text. And then we're not using any more attributes. So yeah, so this is the input. But that's not what I wanted to do. So I think maybe where should we put our actual solutions, because all of these are noise. So let's put them way down here. So the first thing I'm gonna do is split to I guess split no, 2 lists, that's a simpler name. So it's gonna receive the whole string, and then we're gonna return a list of characters. Yeah, so we're gonna import car, exposing car. So we're gonna list car. So this is what we're gonna do. To do this, we'll do to list, and then let's go to elm string docs. And then they have a search functionality there, so we can use that. So let's go into string, pivot split, do we have lines? Yep, we do have lines. So the first thing will be so it's gonna be input dot pipe it into I think I'm gonna do this. I'm gonna go into one in the background. I think this should be installing this Elm packages dot Elm format. I think save this. Okay, that should install, and it's our server running there. Okay, to input, and then string dot lines, and then we have a list of strings now, so we can do list dot map, and then is there a cars? How can you spell it in 2 characters? So what I'm looking for is a list car to list. Oh, nice. String dot to list. Okay, and then we can call string dot to list on all of them. Okay, so that's the first function, but this one is just to make our lives easier so that we can navigate the two-dimensional array easier. So okay, that's the first thing we need to call, and then once we have this, we should have a function that says that's called step, or I don't know. Yeah, let's have a function here that's called, or when you quickly, so what should a step return? A step should return how many times it split the tachyons. So yeah, let's do that. So step is gonna, I don't think step is a good name, and it's gonna take a list of characters, and then it's gonna return and some kind of int, which will represent how many times the tachyon beams were split, and then another list of cars. I can maybe create a type for this so that we don't have to keep repeating ourselves. Type alias grid is gonna be, or I guess we can be, let's call this the manifold, because that's what they told us it is. It's the manifold, and then it's gonna take a manifold. So step is gonna take a manifold, and then return a count and another manifold, right? So step, let's call it the manifold. So what are we going to do first? We're gonna iterate over each item in the yeah, so let's go manifold. Let's look at our puzzle inputs. It always starts in the middle. If it always starts in the middle, we can look at that. But yeah, let's do but we don't know if we are at maybe the step will be the one that does it all, maybe. So let's do manifold dot, and then we need to do list dot map. So we'll be getting this list, and then we need to do a list dot map again, and then this is gonna be, I'm gonna call it process sale, because each time when we process a sale, we're gonna need to look at it in a different way. Think so. So list dot map process sale, but to do that, to compare, we're gonna look at what's immediately to the left of it, what's immediately to the right of it, and stuff. So it will need to know what the current state of the manifold is, right? And then a process sale is gonna be called with a, I think it should be called with a, I guess something like this, map. Oh, is there not a map indexing? I think maybe the function name is different for that. Elm map with index. I think they have that. Indexed map, yeah. So let's do an indexed map, and then let's define this ourselves. So inside of it, I guess we can do this. Process sale is gonna receive a manifold, and the current how does okay the current position we are in the current row we're looking into, and then what will it return? Oh, we will also, I guess it will return a if it's splitted. So for example, let's see how many times can we position. So if process sale, let's say process sale is looking at this one, is looking at this character, right? This is where the split happens. So if it checks what's immediately above it, and if there is a tachyon beam there, it will create something to the left of it and something to the right of it. So if those didn't exist, if those don't already exist at the position, so it will return it. So this will also return a, and then I guess it also takes the current character, but this will return an int comma and then I guess it will return a new manifold, right? Because once we've split this, there's no reason, I guess it shouldn't return a new manifold, because we can ignore all the other cases. So this all will be ignored, and then when step is called again, those will be processed. So we can ignore those, so it will just return an int. Is that what I'm saying? Then so, and then we can call process. I think it needs to be defined before it. So let's say process sale. Yeah, so I think let's do this. Then this should be that. But yeah, the types are wrong. Yeah, so it will. So let's implement process sale. So process sale. It's gonna take a manifold. So it's gonna manifold pose position, our current position in the row, the current position in the row, and then the current character. Let's say sale, and then let's do case sale of, right? So if we see, it will process. If we see as an ace, we are gonna need to create a, it's gonna need to modify the gradient somehow, because our first input is gonna look like this. Are each one of them gonna be creating? So okay, I know what we need to do. So process sale is kind of like our accumulator. It's not a map function, it's an accumulator function, right? So it's gonna do something like this. It's gonna do that. Yeah, it's process sale is an accumulator. So what we need to do is fold this. We need to do a fold. But the fold. Do we just? Would that make this easier if we made this a one-dimensional array? But let's try to implement process sale. So if we see an ace, so here we need to, I don't know, leave a comment saying add tachyon to tachyon. I guess we can say tachyon, and then if we see a dot, we ignore and then if we see a splitter, so we need to do split. So the only case, so it's telling us to count how many times the tachyon beam split. So this is the only case where we will need to return an int, but in both cases, so this won't require us to return anything, but in this case we will need to return a manifold, a new manifold. Yeah, actually we can do this with one loop. We don't even need to call state multiple times, or now that I'm thinking of it. So this should receive something like this instead, right? So it's gonna receive a manifold, and it's gonna receive an int comma manifold, and then manifold, but it will also receive a character. Let's do this, int comma character, and then it will also return an int comma manifold. So let's implement the cases for all of them. It's gonna be splits comma manifold, and this is gonna be I guess row comma column comma cell, and then in this case we'll return split comma manifold. Let's do split comma manifold. This one will also be same thing for now because we haven't implemented it yet, and then the base case will also be, in that case we don't need to match the pattern, this. So here what we need to do instead is do an indexed map, and we have our current row, and I guess it's to call this I and the row, and then here we will do row list dot map, no, this dot indexed map, and then they have their j and cell. So here we'll return I comma j comma cell, right? Let's put this into an int. Let's say grid in, so that we know that we're getting the correct type. Let's return 0 comma manifold. Keep the comparator up. Let's look at the type. So it's gonna be a list of int of cars. Okay, that's correct, but should we, I think we should flatten this. So let's say then pipe this to list dot flat flatten. Is there not a flat? Okay, there is a flat map, but let's do concat. I think concat. Yep, that's it. And then this is our grid now. Oh, concatenate a bunch of lists into a single list, but it didn't like this. Oh, because we removed the, and then let's do list dot concat. Here, let's see the type. Okay, now, okay, so it's coming along nice. So we're gonna need to do some of this, remove that. At the end of it, after concatenating, we're gonna list dot fold left, and then this is gonna be our processing function. Let's call it process cell, and then it's gonna take a 0 because we haven't split anything, and then the initial manifold. What do you expect for fold? Okay, so the process grid and then processing. It's gonna take okay. It's gonna take okay. It's gonna take this first. This is how much you're telling me. And then that, and then this. We can order this. Okay, then do that. Oh, do this. Yeah, okay. This is, I think this is the loop. But there is one thing we need to do since Elm format. Elm format source part 1. Yes. Reload. Oh, you didn't format it at all. I thought it would split this into multiple lines. What if we tell it to do it like that? Then do this. Okay, now it's formatted. Let's start back our reactor. Okay, so now what we need to do is process each cell. The heck? Oh, how long have you been streaming? I don't know. Okay, so now actually let's go over the loop. So when we are at the start, we're gonna need to know what's immediately at the bottom of our current position. So the bottom of our current position is gonna be below, let's call this below index. This is gonna be so our current row plus 1, right? So below index is gonna be row plus 1 and then plus row plus 1 times oh, we need the width of the thing. We don't know the width, right? To do row and column based kind of thing, we need the so it's gonna be row times 1 times the width and then plus the column. We don't know the width. Okay, in that case we can hard code the width. I don't care really. But for our input it will be different, so let's figure it out. So let's say once we got the row, they can pass in after the sale. Let's say they'll be able to pass in list dot length of row. So here we'll have our int and this is the width. So it's gonna be below index is gonna be row plus 1 multiplied by the width, so that will end, and then we move over the column plus so yeah, so let's say, and then we can say list so let's say below equals list at and then manifold. We also need a flattened list so that we do have the manifold right there, but oh no, we don't actually need to do this. So we can do, so below row is gonna equal list dot at or index element at index elm. There is, let's go into the elm docs list. I think it should be in our list. Not member, but is there like a gate or list dot concat drop? That's not the one we want. Any length maximum member, minimum partition, range, repeat, reverse, singleton, sort by, sort with some, take, unzip. Is there no way to index a list? Index into a list. We need to install an extra package for this. I guess they just want us to iterate over lists, not know about their. Yeah. We can actually just install that and then I guess. So is it part of list extra? List extra elm. Let's install this. So there is element index or what do they call gate out. Okay, so let's install this. I think we just need to do, let's look at this, elm install elm community / list extra. Okay, so we just installed the list extra, so we can say let's go up there, then we can import list import list extra exposing gate at, and then here we're gonna say, so below row is gonna be get at row plus one of the manifold. And then here we don't need to do this business, forget about this. We don't need to know about the width. We can index into the array. Okay, below row is that, and so let's say maybe map. So we're gonna need to get a gate hat or something like that, right? So I think we're gonna be repeating this code a couple of times more. So let's say this is gonna be once we have the, if we have this, it will be, so we have the row now, right? We have the row, and then here we can say gate at the current column in that row. Let's say R instead. R. And then it will be a nested map. A nested maybe there an end then or something like that in here instead. Can use end then. Yeah, and then so let's say we below, below is a character. Actually, since we are doing this, we already know we need something like a place art function. Place art, and then it receives a row, an int, a manifold, and then it will return a manifold. So it's gonna be something like place art. At this row, at this column, in this manifold, right? And then we can say manifold list index map. Oh, we're gonna be treating this thing way more. So is there a place art or something like that? And okay, index or place. Let's look at all of the things that return a new list. Maximum by, and then reverse map, set at, okay. Set a value in a list by an index. So let's say for a two-dimensional string, for a two-dimensional list of A, maybe transpose. We have Cartesian product, we have tails, we have groups of with blah 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 blah. So this is not gonna help us, but set at will help us. So we're just gonna need to do something like this. Set at, and let's go back to the error. Then row equals this. If I equals row, then set at column, and the character we need to be setting. I forgot about the car. And then should be the sale. So sale. Else just row. Okay. It's gonna be like this then, isn't it? It's going to like next equals a. It's gonna take an int followed by a list car. Yeah. So R is a list car. Oh, but set set at returns. Okay, let's give it the manifold. Right, it's correct. When we get this, we are gonna need to know what's above us, right? So we're like just like we have a gate at, we need We need just like we have a playset, we need a gate but this one will not, will just be look like this. To still have a manifold, but this time it will be returning a maybe car, and so we need to get the manifold, and then we can get it can return. So we're gonna do let row, or I guess current row equals get add row of the manifold in current row is unknown, and then let's say sale is equals to get add column current row. I guess we have to do a maybe and then for this you can say get add column. I need to do that actually. Manifold get add not get add, but okay, sale add sale, and then this get add will do the correct thing. Okay, so let's say above it, let's say above equals sale add row -1 and add the current column in. So if above it there is a tachyon beam, so let's say, and then let's do if tachyon above, right? This tachyon above was gonna be maybe dot map the sale, if sale equals this, or maybe default with default of, I guess, false in, but this is, it's complaining about, what is it complaining about? Sale out requires the manifold. Yep, it does. Manifold. Okay, so if there is a tachyon above it, right, so now we need to be splitting, so let's do if is tachyon above, then we need to do something, else we don't need to do anything. If there's nothing above it, we don't need to do anything, but I don't think that will ever be the case. But so let's say now we have a tachyon beam above us. So what now we need to know, now we need to see what we have on our left and our right. So let's say left, and so left is gonna be sale at row, not row, but the row will be the same, but it's gonna be column minus -1. Right, so to our left, and then to our right is gonna be column plus 1. So I think we can just maybe just pattern match this. Okay, it's left, right, off. It's indented. Okay, remove that. If we have just dot, I guess what we need to be checking if is either one of them is, if you only have just let's say if we have just pipe on both sides, there's a pipe there already, the original beam. So let's say what they said. So in that case, I think there's mind the two splitters create a total of only 3 tachyons. So for example, let's say so we are this, and then we check what's immediately to our left. So it's gonna be, this one is gonna be the one that creates it first. So this one creates 1 to the left because it didn't say anything there, and it creates 1 to the right of it. So because there was a dot there, but when we look at this, we don't look at those actually, we skip those, so that's get skipped. And then when we get to this, when we get to the other tachyon splitter, we look to our left and we see that there is already a position there, so we just add 1 to our right. So if there is a thing on both sides of our list, we can't do anything return. So yeah, we can't just return the manifold, right? So on our right side, if there is a tachyon beam and we don't care about what's actually to the right, we will do something like place, it will be a split will be +1 because we're gonna add 1, and then this will be manifold or pipe place at a tachyon beam to our right, which is gonna be the same row, column +1, right? And if there is nothing at the first position, we don't care about it. But if there is a tachyon beam to our right side, this will also be the same case, but in this case we will be doing col -1 instead. And for all the other cases, it means that I don't know, either both sides were empty or there is nothing there or there is a dot there. So at this point we can try placing 2 positions at both. So let's say a split +2, and then let's select this, which is gonna be pipe to our right, and then to our left, as well. Let's do save this and Elm format, yes. Reload. Okay, I think those are all the cases we need to be handling to actually split the tachyons. And what else? Am I missing anything? Should we actually call it over our input now? Are there cases I missed? Are there like 2 tachyons placed immediately right next to each other, like a tachyon splitter next to a tachyon splitter? I don't think there is. So what we need to do is, instead of splits, this is actually now a Actually, since we are already running in the browser, let's create a manifold. Let's create a manifold splitter. So I'm just gonna, so let's visualize it. Actually, I'm just gonna ask ChatGPT to do this for me, because uh, give me an Elm view function that will draw this in a grid. So I was thinking we can just call like let's call this what are we doing? I'm just gonna process. I'm just gonna call it process manifold. Process manifold, and this I'm gonna call this. So we can just take something like this. We can do like two lists, and then process manifold, and then take the first one, tuple the first it, and then a string from int, and then we'll be done. But this will only show us the number. Since we're getting the final state of the manifold, why not just draw it? It will also help us debug. So let's just do this. I'm gonna paste it here. Exposing HTML, exposing a div, and then a class, class, and okay, what else? No, okay, no, nothing left. So let's say say split and manifold equals this stuff without the let's see split. Okay, so we can say our text here is gonna be split concatenated word. Let's do that. A string from int of splits, and then here we can do view it's trying to create classes. I don't know, I don't care about the class, to be honest. Let's see what it looks like. Manifold. Okay, for the moment of truth, let's reload this. Oh, I've tapped the reactor, Elm reactor. Let's read. Oh, we only split it 2 times? No, that's wrong. And we can't inject, so we can't inject CSS. Don't use CSS. Why did I end up being true? So it's this stupid thing did div instead. Shouldn't even be a thing, right? Should be just a text. And then this will need to be a pre-tag. Oh, you see what the problem is? We actually need to have, so the splitting is working correctly. So we dropped one here, and then we added one to the left and one added one to the right. But the problem is the dot positions should check if there is some a tachyon beam above them and drop it down, right? Replace themselves with the tachyon beam if there's a tachyon beam above them. We didn't implement that, so it is correct. We only split, but this should be, oh, we only split 2 times. So what did they say? Did they consider that? Did they consider this a one split or a two split? So let's say 2 new beams are created from the splitter. So at this position, do we say we count, we split, it split, the tachyon beam split twice or once? I think that's gonna mess that up, but mess it up. But now that we can see the final grid, it will help us debug. So I think, yeah, so that there is a case I forgot, so we didn't think of implementing here, but this is gonna be relatively simple. So if you are an empty position, what should be doing is exactly this. Is there a tachyon beam above you? That's the question you should be asking if you are an empty position. Say oof, this thing is crazy. It's trying to use a table now because I told it not to use CSS, but we'll try that. Okay, so we can say if is tachyon is tachyon above, then we're gonna return the same splits, but we are going to manifold place at yeah, and then row column, because we are going to place it at our current position. We're going to replace ourselves with it. So splits and manifold. I guess this is gonna be a split, and then should do it. Let's reload this. Nice. So it ended up being 32. I think how do they count it? How do they count this? What? How many times? So we should only just, okay, this should just be 1 according to their count. Okay, so 21. No, that's correct. Now we can actually we actually have a visualizer, but it only visualizes the final state. Yeah. Let's try out this visualizer function, the LLM created. Let's try it out, and then let's comment this, but it will need some new stuff. Import and import. Can we get rid of the borders? Yeah, we can. Let's remove. Let's make this 0. Nice. Now this is a better grid. Nice. Okay. So what we need to do now is stop this. I'm gonna do an name format. By the way, but የድምፅ ፖሊሽን እየመጣ ነው አይደል? I think people above me are doing some construction work or something. በጣም እና ደግሞ like እየተቆፈረ ነው ከጀርባ like የሆነ ምድር የከርሰ ምድር ውሃ ምናምን like it's been like this for ለብዙ ጊዜ. That voice pollution በጣም አለ. So let's do this. Okay, so now we need to create the input. So let's say input, actually let's move and then let's go into source. This was not a input, right? This should be input example. Now let's create example. Let's copy example.elm to input.elm, and then let's open input.elm, and this is gonna be tricky, but let's copy this and then let's put it let's do something like this, and then just paste it in there. Well, let's do that. Right, okay, so there is a space here that would have messed things up, and then there does need to be a space there, but that also would have messed things up. Let's do that. Okay, and then this will be input. Okay, let's close that. You have to force quit this thing. It's like language server stuck here. It's abandonment issues now. When I try to close it, it always gets stuck. The language server is, I guess it depends on if it's we did just paste in a large grid into it. So let's go into our git ignore. No, let's go into git ignore instead of input. So we're gonna input an example.elm. Okay, so let's go into source part 1. So instead of importing our input, where is it from? Let's do it from input instead. Yep. And then let's do an elm format. Yes. Reload. Let's go down. That's our processor. Let's see. I think all of this should be the same. There's nothing we need to change. So let's just run elm. Hopefully it will be correct. Nice. It is a Christmas tree. So, but our answer should be 1672. Let's hope we're right. Yeah. How long did it take us? We started at 4:30 or منعمل الذي عند ساعة تأكل منعمل فاشتغل. Okay. With your analysis of the manifold complete, you begin fixing the teleporter. Okay. However, as you open the side of the before reading this, let's set up commit fit implement day 06 part 1 or day 07 part 1. Day 07 part 1. Let's push this dot. And in day 07 let's copy PR part 1 to part 2. Let's go into part 2. Let's actually close this, it's just creating noise. Let's clear this. Part 2, let's go down. Instead of part source slash part 1, it should be source slash part 2, and then this should be at part 2. Let's run the reactor. Let's clear this. Git ignore, there's our part 2.elm, and then let's go into part 2.elm. It needs to be part 2. Okay, so now we can reload this. I guess let's go back, reload part 2. Okay, so now let's read the question. So so with your analysis of the manifold complete, you begin fixing the teleporter. However, as you open the file of the teleporter to replace the broken manifold, you are surprised to discover that it isn't a classical tachyon manifold, it's a quantum tachyon manifold. With a quantum tachyon manifold, only a single tachyon particle is sent through the manifold. A tachyon particle takes both the left and right path of each. What? With a tachyon manifold, only a single tachyon particle is sent through the manifold. A tachyon particle takes both left and right paths of each splitter encountered. Since this is impossible, the manual recommends manual's interpretation of quantum tachyon splitting. Each time a particle reaches a splitter, it is actually time itself which splits. What? In one timeline, the particle went left, and in the other timeline, the particle went right. To fix the manifold, what you really need to know is the number of timelines active after a single particle. What is this complete? All of its possible journeys through the manifold. In the above example, there are many timelines. For instance, there is the timeline where the particle always went left. Okay. Oh, okay. There's oh no, this is bad. We have to create a new process grid function that will return a new final grid for each fold through the grid. Doesn't even what? So how would we even do that? How would we even do that? Can we do that by modifying our? So at this point, this will now need to return a. I think this actually may be simple. No, it's not. It's not gonna be simple. What? It always goes to the left or makes the. So we make a new manifold when we get to like. So at this point, there will now be two manifolds. So this will now be we'll need to, instead of modifying our current manifold, we'll need to initiate a new loop, a new like process grid call with the. I think recursion might be the way out of this. It might help us all. So if we call process grid on the right of it, and then right, and then this will be what will it be? So here, instead of splitting, we have to call process grid some way somehow. But how does that grid call know that it's supposed to split it to the right? We need to call it after splitting to the right. I don't know. Okay. Or there's a timeline where the particle alternates going left and right, left and right, left and right. Or there is a timeline where the particle ends up at the same point as the alternating timeline, but takes a total different path to get there. In this example, in total the particle ends up on 40 different timelines. Apply the manual's interpretation of the quantum tachyon splitting to your manifold diagram in total. So we don't actually need to know the final output, right? We just need to know the can we keep the manual interpretation stuff like this, and then just go just do this. They say decisions kind of thing. So we're only counting decisions if you think about it, right? So there is a decision here, either left to the right, and so there are 3 timelines that could be generated from this. Either it goes to the left, either it goes to the right, so every single time we see we need to keep another state here. I don't know if that will do it, but instead of counting the splits, we need to count the timelines. So there's one where it goes to the left, one where it goes to the right, and then here one it goes to the left, or one it goes where it goes to the right, and then we check what's on the left, but we see that there is a. Let's do this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20. We don't actually need to do this work. I don't think it's necessary to know how many interpretations, how many, like it's like it's like this is reduced to the final number. If they asked us to list, like, I don't know, which one of this final position is not gonna be covered or something like that, we would have to do the processing ourselves. But I think since it's only the decisions, the timelines are the decisions, so the decisions we need to make. So here we, instead of counting splits, let's call this decisions. Let's do a name in decisions. Right, something like that. And then let's remove split instead of decisions. And then I think each time we get to a tachyon, and then here it's gonna be, there is a tachyon beam on both of our sides. This will mix it up actually, right? This will mix it up. We don't care. We don't actually care. We don't care if there is a tachyon beam to our left or to our right. Should we? Do we? We would. I think we shouldn't. So I'm just gonna I think what I'm thinking is, it's just gonna be something like this. What if we just do this? It's just gonna be decisions plus 2, unless there is a 2 decisions plus 1, I guess 2, and then the manifold. I don't think this will work. I don't think this will work, but let's try it. We only need, oh, that's way too much. That's way too many numbers for each one of them. I guess not for the input, but for we gotta be careful which input we're using. Need to import from example. Input. Example. It's going to example. It should be example. That's why it complained, right? I don't think we need to do the processing. Do we need to do the processing? Do we need to do the processing? Do we need to do the processing? I think we need to do the processing. We need to do this processing. Has anybody finished, by the way? Has anybody finished the quiz? Do you guys actually know? Maybe there is something I'm not considering, but let's try it. Source part 2. And then let's reload. Decisions 44. So we only needed to make 40 decisions. So we created only 40 different timelines, but our decisions counted 12. Because, for example, in this case there are 2 timelines, one where it goes to the left or to the right. In this position there is one where it goes to the left, but this one is the same. So these 2 timelines are the same. So when we're looking at this, we gotta know if like a beam will end up there, or is that what I'm thinking? So these 2 are equivalent. If we maybe just look at the grid right next to our, like 2 positions away from us is another tachyon splitter. We only have one decision, and if there is but one of them will be one of them will need to, right? Maybe we can do the processing here, but it's always splitting, always splitting, always splitting. I don't think this will work, but let's do a double check. So let's do a double check. So let's say, let's just do tachyon to my left is, so because the right one will all just look at it and add the count that possibility. But when we're looking back, if there is a tachyon splitter like two positions to behind, like to the left of us, we only have one decision to make. It's gonna be to our right. Yeah, so let's say is tachyon left, right? And then this is gonna be at the same row, but column -1. So to our left is a tachyon, or is I guess is splitter left to our left. I guess splitter left, or is left splitter. I guess that makes more sense. It is left splitter. If there's a splitter to our left, so if no, I guess this has to be two positions away, so we have to do -2. So if is left, actually no, there is no, okay, so is left a splitter, we only do +1, then else we do +2, 34. Let's do is left minus. Well, if we do -1, this will not have any effect. All of them will be, yeah. So there are some that all end up at the same position, but we don't know about them. So why didn't this work? So let's see this case. So this one comes in, it says, oh, I have two possibilities because I'm a splitter and I have something to my left, but there's nothing to my left, so I'll just have two possibilities. And then this one comes in and, oh, there is already a thing on my left, so there's already, but like you can't really combine them, but okay, so it says there is one to my left, so I'm just gonna add one. And then it says this one, there's already one to my left, so I'm just gonna add one, which should be this. And then for this one it says, okay, nothing to my left, it adds it. Maybe can we visualize this somehow? I don't know how, but this logic is correct, right? So I like to be sure that to abandon this solution method we're following this. I think maybe we have to, but how do we know the different timelines? So in total, how many different timelines would a single tachyon particle end up on? Or takes a totally different path to get there. To fix the manifold, you really need to know what you really need to do to know if the number of timelines active after a single particle completes all of its possible journeys through the manifold. Oh, oh, oh. So we do need to know. Okay, so there are actually we are correct in the previous one, right? So there would be so this is actually correct without doing the so each position we will create two timelines, but four of them according to this will not complete their journey, and completing their journey means they don't reach this end row is what I'm thinking. Yeah. um I don't know. If this feels like one of those that are the trick that I'm not thinking of. Let me close this. Time itself, which number of timelines in the above there are many. So okay, how can we do this? How can we do this? How can we do this? How can we do that? Okay. I think let's just comment this out and try to do some kind of recursion. Let's comment this back in. We need to know actually where they end up, and we are not required to keep track. So it will now return the final thing, the final like process grid function, process manifold function. Instead of returning an int comma manifold, it should now return a list of manifolds, and then we will filter those manifolds to know if like all of them have completed their journey, meaning that for the ones that have like a tachyon at the end row. But I don't what I'm struggling with is how do we make the decisions, how do we make the splits, or how do we make the different timelines. Let's do this. So let's say let's forget about the int stuff, forget about this, forget about that, and let's remove all of this bullshit, and then yep, we're not gonna count anything. Don't think this is a counting situation. Yep. Okay, delete that, save, and here we will be just returning the final manifold. Forget about that. Timelines, for now we don't know, it's gonna be 0, but we'll figure it out. And then let's just have the manifold, and then so let's reload this page. So this is correct. So I think what I'm gonna do is we're still gonna fold, but we're gonna fold over a list of manifolds. The problem is, okay, how can we keep track of the information about it's tachyon above? Dot position should always do that, should always move them down. I don't think this case will change. I think this case will change, but for the splitting, So in this case, when we have a tachyon beam to our left and to our right, there's really no decisions we can make, so there's nothing we can do, so we can return just the manifold. But if there's only one to our left, this doesn't also, this also means, okay, in this one there are no timelines, that are no new timelines that will be created, and then in this one there will be one new timeline that will be created, and then in this one there will also be one timeline that will be created, but and then there will be two. But that's just the splits. So that is, if we go back to right part 1 let's see how we are counting the splits. Okay, it was 1 1 1 1. Maybe is it as simple as that, but we don't know if those are gonna end up at the final position. That's the big problem. We can't do just simple counting, because I think maybe one of them gets cut up somewhere. I don't really know, or some of them are like deduplicates, or okay, so there is a timeline where the particle ends up at the same position as the alternating time, but takes a totally different path to get there. Yeah, so let's do so this will create one new timeline. So in this case we should return an array of one element. In this case we should just return an empty element, or we just gonna be an array of one element, but that's not gonna that is not modified. We'll just keep going. And then if there is one, there we're gonna return. If there is nothing, we're gonna return an array of because we have two choices, so there are gonna be two new timelines that are created. Is this correct actually? Should we try this? I'm tempted to try. Come on, I don't want. After spending all that time removing the counts. Let's undo this. Okay. Fuck. Or did we already try that? So here there are no new decisions we can make. Here we can make one decision, here we can make two decisions. Yeah, that's not correct. 32. Okay, I guess we should just keep this int, because we might not know when we're gonna need to return an int. Okay, so let's say we generated the list. How are we gonna fold over it? How are we gonna process those different possibilities? I have no idea how we can do that. I feel like we can call process manifold on two things, and then finally just list the concat them, right? So I think that's the thing. So instead of doing this, let's say, but how do we so if we say it's a list, and then okay, let's say we added one to the list here. It's not an accumulator function, it's just a map function at that point. It's not an accumulator, but it's a map function. It's a map function, and it returns a list of manifolds. Care about this thing. For this case, we are not gonna, it's just gonna be decisions, and so we just, we're not gonna create a new timeline here. It's gonna be, but is it gonna be process manifold again on this? Maybe, I think so, because we want to move it down and then just process that, keep continuing processing the manifold, and when there is a tachyon above us, here, it's just gonna keep continuing down this road, and then when we have one decision to make, okay, make that decision and keep continuing down that road. And also the same here, we only have one decision to make, process manifold, just keep continuing down that road. Okay, but here there's gonna be two decisions that we're gonna make, so it's gonna be process manifold, that, and then concatenated with, right, process manifold. I feel like I would love it if this is one of those cases where recursion magically solves all of the problems, but I feel like this is one of those cases where you get a Stack Overflow instead. Blah 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 blah. So it's gonna be manifold piped into place at, and then we can call process manifold on this. What's happening here? Why is it complaining? Oh no, okay, let's just do that there. So if there is no tachyon above us, keep continuing processing down the manifold. But what's our exit condition? This doesn't end, right? Oh, if there's no tachyon above us, you don't need to do anything, because this is one of those yeah, just return yourself as a list. Yeah, we gotta be careful with when we need to call process manifold or we don't need to call a process. I'm not even sure about this one. Do we actually need to call process manifold on this? Because it's a map, it doesn't get called again, because we have to specifically call it. But if we are a tachyon and then we're mapping over the list, but then there's nothing above us, we will have to. Oh no, this is not. I don't think this will work. I don't think this will work. Let's just try it, but I don't think this will work. And then decisions. So if we are a dot, we are gonna process the manifold. We have only one decision to make, but if there is nothing above us, if you're just a dot, just gonna return an empty an empty list, right? I think I'm correct on that one. And then same as this one, if there is a character that we don't know about, or yeah, here manifold. There's something wrong here. Oh, so process manifold should return this, a list of this, and then it will do a list.concat after calling process. Great. Right. Actually, the manifold has to be the first one, since we're gonna be doing the map. Now, let's change the order. Is this parcel function correct? Shit, okay, let's hope it does work. Let's just check on the length for now to just know if it completes, if it even completes processing. How long? So we're gonna say manifolds. This is gonna be crazy because I don't think we have a correct valid position. Maximum code stack. Maximum code stack has exceeded. I expected this would happen. Maybe for some of them we don't need to call them. Maybe in process manifold there are some cases where we don't need to map over each cell because so if we don't call process grid on this, process manifold on this, it will not. This is what it initiates. This is what initiates the whole flow. So if we just do something like this, the final result we're gonna get. So like when we switch over to the browser now, is it's only one, or if it's gonna be, it's just gonna be one. It's gonna be one, right? Or in some cases we need to return an empty string, an empty list. So in that case we would return an empty list. Otherwise it will be n. So there are already 240 manifolds. Yes, so in this case this should be empty then. So this should also be okay. Now we can let's call process manifold at that position. Okay, and then maybe in this case it will be just something like this, because we don't make any decisions. It's gonna be, or places where we thought we would need to call, but we wanted to keep processing because we know there are like two manifolds to our left, but for the empty, just return a new, because you're gonna get processed by the next one. Let's try this. Turn test, or maybe we can do this. Even both those. What about this one? No, it just can't be right. So for this we just need to return a we don't actually need to call process manifold. Yeah, that can't be right. We just don't have a good base case. We're just removing all of the recursion at this point. What are we complaining about? Because there is an extra one. Even with this, there is a even with just returning lists for all positions, there is a recursion. How can a recursion occur in this case? Maximum call size, etc. So let's see. We call process sale on an empty. So if so it gets into this. For example, let's say when we initially, so on the first call, so there's nothing above it, so all of these will return an empty list. And then when process manifold gets called, so place at, okay, and then in this call, within this call, so when we get to that, we start calling process manifold. So in that call, within this process manifold call, within the process sale call for S, we pass through this will all return empty, and then they get to this. We get to this, and then we say, is there a tachyon above you? That will be true. We check what the left to the was, or the left to was on the right of it. So we just, so if there is nothing, we create two new manifolds, and that call ends right there, right? But I don't know, I don't get it. Are we calling process manifold? How many times are we calling it? We're only calling it, okay, we're calling it twice. But if we do this, it's gonna be just one. It's gonna be just one. Yeah, manifold's one. Does anybody have any suggestions? I think we need a process manifolds function. It's gonna take a list of manifolds and then process them, and then What if we just call process manifold here, process manifold. That's when we are splitting, so just do this maybe, and then just concatenate those. We don't even get to there. We don't even get to there because it's not possible. Even get to there. Immediately when we call process manifold, here it just starts crashing the stuff. Let's go back to the fold implementation, and then we will have an accumulator and so each process cell call will create a list of, so each process cell call I'm gonna start writing down. Each process cell call should return a list of manifolds, and most of the time these will be just a single one manifold, or I guess most of the time they will actually be empty string or like an empty list, but in some cases there will be a list with one manifold. In some cases there will be a list of two manifolds. And then process grid should get this list manifolds and continue them somehow, keep calling process cell on them. But the problem is every single time we call process cell on them, they will keep on creating more grids, more manifolds. Right. Okay, so let's be generic and let's not ask it for an answer, but let's say I have a grid. Let's be generic. Let's say where I make I guess no, that's not a good we need to process all possibilities at the same time. Just think. Has anybody solved it? Does someone want to give me some hints? How long have we been here? We've been here 2 hours, or I guess 3 hours. How does this get represented in computing? That's basically the question I'm asking. How can I represent this? Is this a function call? Is this collecting into arrays? Process cell will have the potential to return a list of manifolds. Process grid will call process cell on every cell of the grid, so it will have a list of list of manifolds. It will have a list of manifolds. Then it can concat them. So what process grid can do is list. So it will concatenate them into a list of manifolds, of all the manifolds. So and then we can call process grid on each one of them again. So instead of calling them there, we can. So this will be just this will I want you to just return a list, and this should also be a list. And then we can call, so at this point we have a list of manifolds, and then we can, but this one has only one, so and then we can list dot, after concatenating them we'll have to call list dot map and then process manifold, and then list concat again. This will obviously be a stack here. Okay, so the base case is if manifold has ended, or yeah, I think that's it. If what was has ended equals or let's do a simple base case. Let's do a simple base case at least for now. So case manifold. Oh no, that's not a list, so we can't do a simple. So we need to filter out. So should we keep pursuing this? Should we keep on evaluating this manifold or not? That's, how do we determine that? How do we determine that? So this, at this point, after is our if we just say if the last row all dots, that will be true for all of the cases where they are like up here, they haven't completed their descent yet. Maybe let's do let's actually see them. Let's see what they look like. So let's say debug dot log, and how can we convert a manifold to a string? It's oh, actually we can say manifold and then manifold. Yeah, let's see it. Okay, it's making the decisions. So as you can see, it started off right there, it went to the left, 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 it went, actually this is working. It went to the left, 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 but it just got stuck. Okay, so like we need an end case. So as you can see, it couldn't make any progress. It got stuck in this state. Wow. Actually, يا علم debugging عندي لا علم debugger and this is perfectly printed. Okay, so nice. But it got stuck. What's the end position? What's the end? What's the end? How do we know that it has ended? Can anybody like know? Um, is there just we have at least not empty but at least one or more tachyons at the end, right? Let's say has ended. It's gonna take a manifold and it's gonna return a boolean. Let's say bool. Come on, bool has ended equals manifold equals. So we're gonna say list that last. It will be part of the extra. So let's say I think it will be part of extra. So let's say last or the last. So let's say last manifold and then maybe dot map over the row and no, let's just say elam element elam index elam indices. No, that we want to say exists or is in. We can just do elam, but don't I have a I'm gonna check. We're looking for something that will return a bool. Take one, all different by set if update if. I expect there to be an exists or something. Group while, group with is prefix of, is suffix of, is infix of, is subsequence of, is permutation of, not member. Negation of member. Okay, member. Yep, that's what we want. Is member at least once, right? So at least once, and then maybe with default false. So let's say if has ended manifold, if has ended manifold, else if it has ended we will say we will return the manifold itself, a single manifold. Is this how it should work? Doesn't seem correct. We need something to collect into, or then here maybe. I think maybe we just return this then. Has ended. Do we ever get into this? So ended, let's say ended. It never ended, so that didn't work. There is an empty string in front of it. It's going to example open source example.elm. Show the case. Other is not returning true. Last manifold is a our manifold type is a list of characters, and then we're checking if pipe is a member of that. Ended did get called here. It ended. But it got okay, and then this one got called, and that one ended. Okay. No. Okay. This hasn't ended, right? I don't know. I don't think it's just a matter of. It's just a matter of. So we are gonna say. Yeah. Okay. I don't know. For example, this one got logged as ended, but here you can see that there is one that's waiting to be dropped. It's not at the end. Having ended logic is not correct. Ended is getting called multiple times. Manifold ended. Let's go down there. Yeah, ended is being called multiple times, but it's just getting stuck. It's just getting stuck. Maybe we have to say list that unique or elm unique. Okay, so it's part of, okay, it's a unique maybe we have to say after processing each cell we have to say unique, maybe. Whoa, did you see this? Did you see the logging? It was processing it perfectly. I'm gonna reload the page again so you can see them dropping in. You can see them dropping in. But our end condition is still not correct. Maybe just return an empty list if it has ended, but it's not correct. But this is actually wrong. It's not splitting them at all. Huh? The previous one was correct. Oh no. Okay. Is it because I added this? They are being added all at the top for some reason. When I do a unique. has ended is, if we can only know that it has ended if I think this is it. Have ended is if this returned an empty list, right? No, if it returned the same. Am I correct on that? If the, let's say for this one, let's look at one that has ended. So okay, so this one ended, and then if we call process cell on each one of them again, let's say for example on this one, it will see that there is a tachyon above it, and then it will check if there is so it will check what's on the left, what's on the right. So in this case there will only be one thing on the left, but it will now try to add one to the right. Yeah, fuck. But I think the unique call is gonna make a difference. It's making a difference. This one came from that. The unique call is making a difference because I'm seeing more cases. But do they mention how we can check end in the analogous state with quantum tachyon blah 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 center the manifold to expose the left? The problem is we don't know when we got to this state. Oh, what's the private leaderboard code? I think I posted it on the channel some time ago. Where is it? Here it is. We have the processing function is, I think it's done, but the only it's it will keep on splitting them. I want to keep on splitting them if have ended. Oh, I know what it is. No, that's not it. The count of the tachyons, if we have at least one tachyon on each row, is that it? Have ended is there is at least one tachyon on each row, and then it has ended. Let's look at the alternating one, for example. Let's say, for example, it made this decision to go there, it went down, it made the decision to go there, went down, it went the decision to go there, went down, it went the decision to go there. Yeah, I think that's it. So let's say manifold or all, right? All member manifold. And then let's remove the unique. actually maybe we need to do something like this here, manifold, and then if has ended, if has ended manifold, then just manifold, else process manifold. That's how we should do this, and maybe we don't need to do that now. What is this? Nothing there. I don't know why it's complaining. Elm make source part 2.elm. It's saying the name manifold is first. Okay. Oh. So let's say x, if it has enter x, and then return x, and then otherwise process x. Oh, if I spelled this correctly. It's saying okay, this one returns to this one. But it's the same thing, Ko. I just moved that check down here. But that's قدمت no code no دقامي. Right? This shouldn't make any difference because we were already checking for that previously. It shouldn't make anything. It shouldn't make anything happen. Elm reactor. Yeah. So I don't know. Say debug log ended, and let's put the parentheses around this, and then let's remove this logging here. Then let's see. Oh, ended is never true. We didn't get, at least we didn't even win one. Wow. All member manifold is always all. For all is okay. Determine if all. Oh, not all, because this one will be S. So if all, not all, take, no, I guess drop. What I'm thinking of. Manifold pipe, and then drop right, drop left, drop drop the first n, so drop 1, the first row, and then all after that should have at least 1. I think that's it. No, this hasn't ended. Where's the pipe in here? Has this ended? Let's see it down here. Nah, we don't have the formatting here. Let's see. Let's see. There is no. Am I? Is my eyes deceiving? Are my eyes deceiving me, or I don't know what is. No, let's save that. There is no drop first. It drops the first thing, or should we then do take? No, I. How is the list ordered? This is the one that should have been dropped. But this hasn't ended. What are you talking about? But it's not, the bottom row is filled with dots. Not there's not a single. Let's see the first ended that was logged. It's this. This hasn't ended. What? There is no. Why is that? Let's go into the Elm repo and paste this in. No, not the whole thing, but only this. Copy x equals dot, and then let's say list dot member. How did that return true? X false. What the is all lying to us? All determine if all elements satisfy some test. Okay, then that's I think it's the drop maybe that's causing this. Let's say car or row member or member S row. No, not Elm reactor. I don't know what's happening, to be honest. I don't know what's happening. What are we? We're logging the incorrect thing. Shit. Okay. It should be X. Yeah, it keeps on so if we look at this, it's ping ponging between these two states. The last the leftmost position كاره بحالا that doesn't get resolved, so it ended the final position, and then the other call that was like right before this, so ending now, so that the last time it splits according to our array, so it's at our manifold it will be something like this, and then this would drop, and then this has ended, but it will keep on. Okay, now is the time where we introduce unique, but where should unique be called? Maybe here. Unique. Is that the case? Then we iterate between random different positions. Let's look at the history of the thing. It's actually doing it. But there is a missing final. I think this is correct, right? So it's going up and then reducing all of the position. So this is where we went to the left, and then this is where we went to the left, but in the last position decided to drop instead. And then again, this is where we went to the left, and then this is where we went to the right again. This is went to the left, then went to the right, left, right, left. This is where we went to the left, the right, dun. It's reducing all of the possibilities. I think it is correct, but I don't know why that got repeated. So this one, no, it didn't get repeated, so we just had one at the end, but and then this got considered as ended. Okay, so it should be our end clause is if all of them have one, wait a minute. How does this one have all of them ended? But there is one here that hasn't been dropped yet. So what was the decision that was made here? There is no position. There is no situation where we were placing two elements at the. But let's see. Okay, so this gets called. So maybe okay. So this gets called again in process grid. So what will happen is it will go down, and then create a list for each one of those, even though there is an ended one. So I think maybe this call needs to be here, and then I don't know, I'll just return an empty list and then else. I don't know, just what the fuck. It keeps on like ping-ponging between the same end positions. So let's say this, but let's say this. Let manifolds equals, and then in, and then let's in if all has ended manifolds, then return manifolds else. I think this is it. I don't know if this will help. Oh, we removed all the debug logging. Let's do all of them, even after uniquing, even after calling unique on them, there were no situation in which all of them ended. There was at least always one that maybe if the manifold has ended, we're not calling it. We're not even. We're just returning an empty list. We shouldn't be. We should be returning a manifold, but this should be something like this actually. To be honest, it should be like that. But you can see it dropping, and then they're iterating with on the same final positions. I don't know. Let's see if ChatGPT will help us, because we've already spent too much time on this. Is there a bug in this? Are we missing a base condition? We want to process each possibilities. Maybe we need to see. We need to create a kind of wrapper around process manifold that's called ended, right? So it will be some kind of, let's say, it will be this. Let's copy this, but no, just do this. It will have another list of manifolds, and then they get this. Do we missing no progress base case? So you can't get in a solution where has ended is false, manifolds equals manifold, no changes, all has ended, manifolds equals false. Then you recurse. When you effectively do the infinite recursion, yep, that's what we're getting. So new states or only the same states as before. So okay. If stuck, then no other possibilities. Okay. I don't think there is a. I think all of them reduce to the last position. I don't think any tachyon gets stuck at an empty position, because as long as there is an empty space below it, it will just get getting dropped down. Else if yeah, it's still doing it. Still doing it, but these are like these are all of them are repeating. So if we reload the page again, it's only the final positions that are like bumping around. No, okay, number one, that's it. The second one, empty successor list to all. If manifold is an empty list, then all has ended is true. This means if no sales produce any new value will hit. Okay, this doesn't really matter. We wouldn't be calling them. Has ended might not mean what you think. ignores the first row. All member for each row of a list card, check that every row except the first one contains at least one. Yep, that's the end condition. A more typical finished check would be something like no more interesting sales left. No, that we still no, that's not it. Maybe the thing it mentioned about stock positions is correct. No. How would we memorize? I guess not memorize, but because it is stock. It keeps on. We're cycling between the same like 4 or 5 possibilities. Let's go back up. Let's say drop. According to our actually it is invalid, so I'm gonna do this is invalid is in how did I spell invalid? Okay, if it's invalid if there is more than one tachyon on each row. That's invalid. So let's say if let's say count, is there a count? Yep, count. So no, let's do map. Oh no, this invalid is for a row. Oh no, if any, so any, that's what we want. Any of them, if any of the rows, their count of equals tachyon for the row is greater than 1. If it's greater than 1, what's the error? Okay, double equals is not a okay, something like this then. Okay, so it's invalid if any of the rows have more than one tachyon. There should only be one tachyon. So let's say let's do list.map process.grid and then do list dot no, I guess list.concat and then list.filter. I guess filter will is good. So and then I guess this code is valid. I guess we should convert this to be is valid if and then it's just less than 2, I guess, or less than or equal to 1 is a good check. It makes more sense. if any, or if all the rows have at least less than or equal to 1, they are valid. Either they should have nothing or they should have one tachyon. I think that's it. This if is valid. This is annoying. Okay, but then we're getting stuck on okay, this is correct. It's correct. Keep going. That's correct. Keep going. It ended and then it went back up, nothing. Okay, back up, nothing. What? Shit. It removes the last element and then it just goes back. Okay, so let's do this. Okay, it went down. Just this is correct. Correct. Did anybody give it? Oh, shit. I use dynamic programming for part 2. Second question is tough. Not enough. Not that hard though. First, also thought it's try on the example input. It will be easier to debug. Yeah, we're using the example code. Dynamic program, it will be very hard to do without brute force or greedy. Yeah, we're doing brute force. I think maybe we should memorize them because it's cycling between. I'm cycling between the same states, if you can see. So this is the same state as this one, but we've already seen this case. We've already seen this, and then it goes back up. We've already seen this case. We've already seen this case. We've already seen this case. It's cycling between the same thing. Let's see. Yeah, okay. Yeah, this is okay, so is empty manifolds. And I don't think this will ever be true. The first core of process manifold will be okay, that's correct, and then it goes down, and then after it has finished, it will the other process let's log down. Let's do this. Let's remove this debug here. Then I'm gonna log this to see debug.log manifolds. I want to know how many manifolds the first call generates. I think it should just be one, and then it's the same list over. Okay, so we're just stuck, and then we keep producing the same list over and over again because okay. this is where it finished reducing the first pattern, right? So it went, they went, did it, went to the left, it kept dropping, and then all of them are the same, right? Like we did call unique on this thing. And then this got logged 967 times. Okay, I think let's remove this and remove that, remove this. I think what we should be doing is, this is good, this is good, return only the unique ones. I guess is valid stuff is not gonna help us. And then in process sale, instead of returning, we should let's go back to calling, let's go back to, let's try, and then let's add the debug log back here, debug log manifold, and then no. Instead of doing the recursion from the process manifold, let's do it from the sale processing logic. So here we're, instead of creating the lists, let's do this process manifold, and then that, and for this one you saw two positions at the left and right, so I think that should just be this, because these are an end case now. And then process manifold for this, process manifold, like that. And then here it's gonna be process manifold, because we're making a decision, we will call this, and then concatenate the result of that to this process manifold. If there's a tachyon above, we want to keep processing it, but this will keep on return. Okay, I think that's what we're supposed to be doing. I guess this will be way too many calls, way too much recursion, but now we went to the right. Now we started with going to the right. Right. And then we finished. How do we end up with this? I don't get, how are we ending up with this state? That's what's crazy. And then that drops, and then it just keeps on. Process manifold will check if it has in there. uh, then or let's add another check here. If no if is valid, no if I guess else if is valid manifold, and then the base case will be empty list. Else if then we're mapping, not even folding. I think we're losing the original call. So during the first call, it will call process manifold again, go in and take the push it down. So this will push it down, call process manifold again. I think maybe these ones don't, if we're not making a decision, or I guess this one, if we're just gonna be dropping one position down, it's just not a, it's not a, that breaks it. The previous one was correct, I think. The old one we had was correct, but it was only, I think we were losing when we map over the list for the first time, we update the manifold to add the first, to start adding the tachyons to the left, and then we lose the original manifold. So all the other recursive calls will try to go up they start from the manifold that already had those elements to the left of it. The example input, I mean the input used to explain the problem. Oh, nice, that's good. That's good. I don't know. Should fold over when we are given a manifold. When we are given a manifold, we should fold over each position and return a list of the possible moves. Yeah, the possible moves we would make, the possible changes we would make given the current manifold. So it's undo. That didn't work. So this is correct. But so here, instead of mapping, we should do a fold. No, let's go back. We should do a fold left, and then let's go. We're gonna start off with an empty list. This is gonna be our accumulator of list of manifold and then this is gonna be our accumulator. And then what we're gonna do is place this in our accumulator. Place that in our accumulator. Press, then do that. Accumulator, same thing here. Come on. I think maybe the recursion is gonna always keep happening because the input is this just requires too many recursion. Like the stack size, the maximum call stack size error is gonna keep happening. So I think we should introduce memoization as fast as possible, like right now. So let's do that. But before we do this, we gotta do that. That doesn't happen. We gotta do that, and then that's added to the accumulator. And then I guess in this case we're adding nothing to the accumulator, so just return the accumulator. I don't know how this would be different from what we had. I don't know. This is not gonna be different, right? I don't think this will be. And then accumulator, and then accumulator. Let's go, like for the first code we'll drop it, and then for the second code we will see that both of them are empty, both of our sides are empty, and then we'll add one where there's one to the left and then one where there's one to the right, and then we can say process sale takes manifold in front of them. Accumulator is the second one. The type mismatch. Okay, type mismatch. The function cannot handle the argument sent through. Okay, it should. So we mapped over the manifold, then created an ij. Oh, this will now be a list. Large dynamic. Let's go ahead and make let's look at the type then. Okay, in what is this? Yeah, and then we fold over that list. When we fold over that list, we should be getting int comma car. What are you complaining about? Manifolds. What is this? The argument for that is a list of int comma okay, but that is piping a list of manifolds into it. No, that's not a manifold. You know those things. Let's bring him further from this. Let's just say that. Process sale. Take the manifold, which we already gave it, and then the accumulator, which is a list of manifolds, and then the current sale, and then it returns a list of it returns a list of manifolds. And then let's remove what's after it. So what's after it? What? I don't get it. This argument is of type bad fold, needs a second argument to be accumulator and X, and then accumulator. That's the type definition of a fold. What the heck is it talking about? The first argument is X and the second argument is the accumulator? What? I forgot what we are trying to do. Okay. So this is, and then this is this. Stock. Okay, what is this? Of course, they have to switch positions now. So we fold over the sale, and then we keep on accumulating stuff to our list. But now we are not even calling. So we call here, we call process manifold on them, but see, S dropped it, and then the splitting is not happening. The splitting never happened. Why? Because we added it here. We added it to the list, right? in the first step. You can this is false, then we end up in here, and then we go over the list again, and then this should be when there is a tachyon above it, but there is no tachyon above. I think there is no tachyon above it. Which manifold does it check? It checks the manifold we gave it. Blah 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 blah. Is this always returning false? Log above. Yeah, for some cases it's returning true, but where are those being printed? I guess those didn't reach this position yet, so it's gonna be something like let's say debug dot log them here. Let's say manifold. They are being generated, so it's dropping them, but they don't keep on going down. They keep on going down. They don't keep on going down because why? They're being caught by some. If we haven't ended, we call process manifold on them again if they haven't ended, and these clearly have not ended, and then when they come in they don't produce new grids. This went down 2 steps. Oh, what? So this one, oh no, okay, example. How do we have an empty at the front of it? Let's reload. What? Shouldn't be happening. Reload. So here, when we process the sale, we always append something to the list. Okay, so there are cases in which it got called with, so, and then I guess we need to list that filter is empty. Yes, it's valid, and then is empty. No, not. I guess we can't invert it, so exclude only look at the ones that are not empty. I want this list to keep growing with all the possibilities, but um, the original condition is also ending up here somehow. The original manifold is also ending up here somehow. Um, what if we didn't do the unique? Shouldn't affect anything. Yeah, we're not actually generating. So the first call is correct. This generated a list with that one position drop, and then it should return 1 2. So one with the left, one with the right, one with the left, one going to the right, one ray going to the right, one ray going to the left. And then how does this end up in there? How does that end up in there? The original manifold, how does it end up in there? How does it end up in there? So what we're doing is we're creating a list of manifolds by calling process sale on each one of them, and then our accumulator is empty. So for cases where it's not supposed to do that, they'll be empty. But I guess in this case, um, we also need to know what the manifold it was called with looks like. So let's do that here. So debugging, I guess let's call this time, I guess, generating for, and then let me just reload this. Let's go up. It's generating for the original. It generated this, and it's generating for this, and then it generated this. I guess we're gonna have to do list.filter, list.filter all the ones that if, but I don't know. I think maybe we can handle that here. This one is the same as what we were called with. Are we manually concatenating that ourselves? No, we're not. Generated the one to the left, generated the one to the right. One to the left, one to the right, and then the code. It's which one of these added? Which one of these cells could have added it? I think S could have added it again. So we need to add a condition here. Late. If there is already one, don't add it. Or then don't generate a possibility. Actually, this should be true for all of them. This should be maybe. So place add, right? Place add should only place something there if there is a dot. There is no case in which we place over something else. So place add should first do. I guess cell add. Okay, let's do. If cell at row, I guess case cell at row column of it just some dots, and then do what we're supposed to do. Just otherwise it should always be nothing, and then this should be I guess we need that. This should be called on the manifold, and then this condition. Yeah, type mismatch expected a maybe a returned a maybe car. Oh, and then this will be a manifold too. Okay, so and then we can actually make our accumulator be a list of maybes, right? And then we can get the just I guess. Turn just the accumulator. Okay, so place ads will so now we're narrowing down the so okay, here we need just or something like maybe a list of lists, maybe a. Don't I have that here? Do I have to refine that myself? Maybe it's part of Elm, maybe just values or something like that. List maybe a map for. Is there a list? Is there a list mentioned in this? No. Okay, a maybe mentioned in this. Maybe filter map. Oh, I guess filter map is what we want. So then this dot filter map over identity. Now we shouldn't be seeing any repeating manifolds. So is so now one to the left, one at the bottom, one to the right, one to the left, and then what's the next? So generating for this. So do we get generating for list dot filter? Is valid. What? What? Yeah. Did it just work? I think it just worked. What was it? 40 possibilities? 40 different timelines. I think, did we just figure it out? Holy shit. I'm gonna remove the debugs and and I'm gonna remove the debugs. Wait a minute, did that just work? Reload. It's still manifolds 40. Okay, I think we figured it out. Woof. Finally. Holy shit. So we need, let me just do this. So let's do something like this. Let's do view manifolds, and then give me a list of manifolds, and let me just view manifolds, and then let's create a div, and then let's just call list.map view manifold. Let's just do view manifolds. I guess this should be timelines. I guess timelines, and timelines, and list should be timelines list dot length string from int of the manifolds. Div is not there, import div. This is it. So all to the right, all to these are like, oh no, these are different. Yeah, these are different, so okay. These are all the possible dimensions. Maybe we need a x, and then that's the manifold. We're gonna call manifold on this, but let me just add an h. I'm gonna add another div, and then div, this will be its child, and then in front of it I want to add an HR to just help me see it better. Okay, actually now let's just run it on our input and hopefully we'll be done. Result ላይ ትክክል አላችሁም ቢለን, I'm afraid of that actually. That's why I'm stalling. I'm actually stalling. I don't want to run it. I don't want to know that it's wrong. Okay, input, and then it's just a reload to get the final answer. What if we get a stock exceeded? It's calculating. Hopefully a stock exceeded. Oof, maybe the stream is gonna break. We're not memorizing anything. Wait, don't crash, please. Oh no, we should be memorizing stuff. I think that page is gonna crash. Yeah, same here. It's been running for a while. Shit, we need to memorize stuff. So if you actually memorize the, so I think in our case the whole thing is, most of the work is happening in process state, so we can just store a map of the manifold to the list of maybes it generates. So it will be a map of manifold that you need to manifold. The manifold will be one of the keys, and then the rows and columns will be, and then I guess we're doing too many. It's not gonna work. I don't think it's gonna work. How let's I think we've been streaming for 4 hours or more. How do I know how long I've been streaming? Okay, it's been 3 hours and 38 minutes. Okay, it's been 3 hours and 38 minutes since we started streaming. And how long should we wait for this to finish? Or should we just, okay, while this is running, I don't think it's gonna work, but let's memorize stuff. So if we create a map, elm map. Okay, that here it is on a standard library. I guess it's called a dictionary, so let's do dictionary. We can create a dictionary that's indexed by these two things, and then we'll just keep adding stuff to that. But that's not gonna help us. What's the most expensive stuff? Where is the most expensive stuff happening? Where is the most expensive stuff happening? I think maybe let's cache this process manifold. How many times that process manifold get called? Let's cache the whole thing. For this manifold, these are the list of manifolds that will be generated, right? So let's do some kind of, so I guess this will be process manifold inner. No, it should be inner, and then there will be process manifold like this, process manifold, and then no, this is the read one. It's gonna call process manifold inner. Maybe is our approach wrong? Let's call this inner. Okay, that's what it is. And then here let's introduce a new let's cache, let's say type manifold cache type alias manifold cache is gonna be a dictionary of a manifold to a list of manifolds. I don't think that's gonna help us a lot, to be honest. Bro, I'm saying your site, are you still working on the Ethiopian Dama game? It doesn't have any instructions on how to play. The answer is 1e to the what? If 40 took this much, imagine 1e to the power of 40. No. Yo, hi Kranz. Yeah, so 1 to the power of 14. I guess 10 to the power of 14. This is not gonna work. I'm going crazy. Caching is not gonna solve it. Caching is not gonna solve it if that's the case. Caching is not gonna solve it. Let's try it though. Let's try it. It's better than just waiting for it to finish. Let's do a dictionary of this, and then once we have finished generating the manifolds, let's do new. It requires to how do we add stuff? Add, insert manifold, right? And then here the else if or we can say if we can wrap all of this in a case of get manifold of I always choose like if we were using REST, I could use Rayon, do like some kind of memoization stuff from Ether tools and stuff like that, and we'll be done with the brute forcing solution. But I'm using like a stupid functional programming language, and it gets all messed up. Manifold. If there is a if there is manifolds, so let's do get manifold, and then if manifolds, then manifold this nothing, then let's do the compute, and then here you would need to call process manifold inner on the list with the new dictionary. Just manifold nothing. I don't know what's that complaining about. Maybe some kind of indentation issue. Make I guess I'm getting confused. You don't need prepend it with this. That's what you do in OCaml and Haskell, not in Elm. No, there should be manifold cache here, and then a manifold, I guess let's call this the cache, and then everything the cache. If it's in the cache, return it from the cache. Let's call it with an empty first, and then here it's complaining that we need to call it, add it to the cache. Let's call this rename this to new cache. It's still going. Let me just close this. I don't care, it's not gonna work. Elm reactor, and then let's go to localhost 8000 part 2. Okay, we're still loading. Okay, close this. What else do we need to cache? And I think caching the process sale function is gonna help us more. So let me just move this manifold cache, and then this is the type, and then we'll need a new type that's called a sale cache. So we don't even need to look at the cases of, we don't need to generate new cases for the current sale. Tired. Okay, so here we will need a sale cache, something like that. Sale cache, a sale cache, and then I don't know what the type should be. Should it be dependent on the manifold? I think it is, because whatever we're gonna generate depends on the current state of the manifold. So this should look something like this. So the keys are gonna be, it's gonna be a manifold, and then the cell we're looking at, which is defined by the row in the column. So if it's int comma manifold, and then what will be the cache? It will be a list of maybe actually, to make our life simpler, let's go back to the example. Localhost 8000, and then source part 2. Of course we created an error here. Let's remove that. At least we can see if the good thing is, since we're in a browser, we're gonna be able to render it and stuff, the final result. We're gonna be able to render the final result. I'm gonna if all has ended, then I want you to do something like this: date underscore debug. I want to look at the if our manifold cache is doing anything. Let's say cache, and it's gonna be the cache, and then in. Let's see what it looks like. Okay, there is some stuff in here. So there is some stuff in here, but I don't know if they got used. Show more, 34 kilobytes. What? I think we're just caching each step, so this is not gonna help. We're caching the whole thing, and I don't think these things are being duplicated, because if these things were being duplicated, these final links wouldn't be the links of the timelines. So instead, let's delete the manifold cache. Let's instead do the this is also not gonna work because it's dependent on the manifold. It's dependent on the manifold. What we need to do is eliminate the process sale function. So what we should do is create, when we're given a function, find the array, and then just, so we need a function that will be given like, or follow it to the end. It can't do that though. We need how many of those would we need to generate? We don't know that. Yeah, I don't think this is not gonna help because it's just duplicating the list of manifolds. Yeah, it's not gonna help us in any way. Move that. Yeah, it's not gonna help us. Maybe early returns. How can you do an early return? You can't do an early return in something like this. Yeah, it's as simple as it's gonna be. Do you guys have any suggestions on how we can do caching? So are you doing the code in random language day? My friend is doing the same. Yeah, not random languages, but I'm trying to do like every new day in a functional language. In another functional language. I like the part where you display the timelines in the browser, but L might not be might not be for today's. Yeah, it was. I was deciding I decided the language before I saw the puzzle. So yeah, it's like compared to Neovimo. Helix is good. Like I like the motions and stuff where you select and then you perform the action. You don't say like, for I think in Vim you do like delete and then you decide what you want to delete and then you can say W to say delete word. But in Helix it's kind of like reversed. So you have to select by using W. I select the next word, and then after selecting it I determine what I want to do, if I want to capitalize it or if I want to make it lowercase, if I want to delete it. So it's like select and action, not action then select. And then their language server integrations and stuff is nice. And then you don't have to like worry about plugins, updating your plugin manager, installing plugins. Everything is built into Helix. To get started working on like a new language, working with a new language, you just need to install the language server, and just Helix picks it up and starts working. Yeah. Yeah. Okay. I don't think caching is gonna help us. It's like we have to rethink our approach completely. Caching is not gonna help us. What would we even cache? If we cache this with what we're gonna generate for a given manifold, and while we are at the given row, yeah, it's not gonna help us. uh, we can't even parallelize stuff. uh, Process still can be is like perfectly parallel parallelizable, and then we're not even able to do that. Process manifold is also parallelizable, I think. Yeah, none of them depend on each other. It's just the input is just too big. That's what it is. Just let's look at the input source, and then input dot elm. It's yes, okay, this is the list. And then we're iterating over each character and then generating new maps like this, like, and then we're doing that again and again and again and again multiple times. This one doesn't take that much. It's like no, that's part one. Let's go back to part two. Save. Each one of them get called with the same manifold. Since each one of them get called with the same manifold, I think this sale art and place art functions, I think maybe parallelizing those would be correct. I think let's do that. So let's say, I think this will be get sale cache, and then we can create a new cache for, yeah, get sale cache, and then can do a would a place art cache make sense? Well, where are we? We're deciding, like, if we, like, for example, we go down, we decided to place there. Is any call after us gonna decide to place there? No. We got to the first tachyon splitter, we added something to the left of it, and then we're the only one that's gonna try to do that. The next one try to do it in the right. So I think maybe gate sale caching, gate sale, let's try doing adding a gate sale cache to just, I don't think we need to do and then this will be a this, and then it's this character, simple cache, simple memoization. So because we're traversing a two-dimensional array, this could be what maybe help us. It could maybe help us, maybe, I don't know, I'm not sure. First it's gonna take I guess one of the last things it takes is gonna be a gate sale cache, and then cache case get row comma column from the cache. And then if there is something, just no, it's just maybe one should be a maybe. Oh, there is something, and then just return that. If it's nothing computed, then we can say desktop insert net course in, and then this is the new cache is gonna be that insert at the given row comma column the current value, and then in what so let me okay, the cache and then manifold, and then finally it should return thing like this. Exit is there a built-in memorize thing? Elm memorize. Somebody has already created some kind of memoizable thing, but how does it work? If you have a function int bool that is expensive to compute, Elm memo pure, yeah, it's not gonna work. Let's create our own memos. Followed by a cache, and then okay. Okay, so let's now update this whole thing. It's gonna be called with a manifold and a cache for each cell. comma cache equals place this no equals this in manifold, and then here we have to add the cache before the, so I think shadowing the name cache is first defined here. Elm doesn't allow us to cache to shadow it, so I guess we gotta just append, keep on appending, and then this is new old, I guess. We can add new manifold into this. Oh, and then oh no, this cache cannot be used for the next call. In that case, this will be something like this. It will be part of the accumulator, empty comma, and then we can go back up here. Instead of being from there, it should be from here. Okay. Okay. All hash comma that, then remove that, and then this will be cache comma accumulator, so it's gonna be new cache, and then this, I guess we can call this new cache. New cache will be okay. Should be with all cache. Same cache, I guess. Okay. It's gonna be saved. No, this is gonna be moved out to somewhere here, and let's say above will be something like this, but it will equal this, and then it will be called with cache, and then this will be above piped into, but the thing is this is gonna be something like this. Let's say cache 1, right? Then here we need to use cache 1, and then here we will return left comma cache 2, and then this will be right comma cache 3. I don't think caching is gonna work. I think this is just too much work for it not to work. Not gonna, this is should be this 2, which will return 3, right? And finally we can call this with cache 3 comma that, and then here we're gonna need to call place at, so we're gonna generate a cache. So it's gonna be new manifold and new cache equals this, remove it from here, call it at the end, cache 3 and the manifold, and then it will return something like this, a new manifold manifold, and then new cache. I guess that cache is what comes from. Okay, something like similar to this, would say. Let's copy this, I guess. The only difference is gonna be -2. And then here we need to do both. We need to do this. Twice. I guess this is new manifold. Right, then new manifold, left, new cache, left, new cache. No, I guess all of them will be using cache 3, but this will be new cache 1. New manifold right, followed by new cache 2, and then no, I guess new cache 2, followed by new manifold right, and then new cache 2, followed by new manifold left, and then no, oh, okay, so it's gonna be something like this, followed by new manifold right, new manifold left. Okay, and then this case I guess cache, accumulator, and here just gotta get above, then use above instead, and then I think we're using the accumulator correctly now. So we place that, we get the cache, we get the new cache, we return the new cache, we check what's above us, -1, we give it the cache, we get a new cache, is tachyon above, we check that, if it's, we get what's on the left with the cache, and then we use that cache to get what's on the right, and then we compare those, we return cache 3, the final cache, and then we use cache 3 to get a new cache but when we're placing, and then when we're placing we use a new cache, get the return that cache. This is correct, I think. And then what we need to do here is tuple that second, because we don't need it after the processing is done, but let's do a tuple.map. It's not gonna help us, I guess. I want to see what the final one is. I guess we can do this. We can say I want to see what the cache. I guess let's try reloading it, and then let's just do input. I don't think it's gonna help us. Let's hopefully it will help. Yeah, yesterday's parsing problem was crazy. Yeah, it's taken me 2 hours for each. We're already at 4 hours now, and yeah, the caching is not helping us at all. I'm gonna take suggestions from the Oracle. How can we make um, process manifold faster, especially for larger grids? I don't think we have duplicates, but maybe we do. Um, they said at least two of them end up at the same position, so I think that might be a good idea. Uh, let's do that. We can do that by adding a list that unique, or I guess just a unique. This analytics rather unique, but let's go back. Let's make sure that it doesn't actually mess up with the results. I think it will. I think it will. Was it? No, it won't. Okay. In that case, let's try that. Input. What is this thing? Deduplicate the manifolds per layer. Right now you can easily create identical manifolds multiple times. It's trying to use a set, but you can call list.unique on this. It doesn't know about list.unique. You will need to adjust process sale to no longer pass around the cache, just process manifold inner global cache manifold. Yeah, we tried this. It didn't do anything. Consider a faster manifold representation. Okay, it might have a point with array. Okay, I think it has a point. Elm array. We should use an array instead. Oh yeah, I think it's what we should be using for this. Yeah, I think the gate is constant time for arrays. The for list it's on, so I think it's correct. Let's go down to manifold, and here let's say array and an array. First, I think I'm gonna let's just keep it. I guess array. If we are using an array, maybe we don't need to use the list.map, trying to list, and then list.map array dot from list, and then array from list. Let's just do this format. Okay, and let's see where we're okay, and then this will be array dot map. I guess here we can just do array dot to list at this point, because this is the final thing. What is it saying? Why don't array.map work? Array.map, and then this should be array there. Oh, and then I guess we can call list array to instead of get out there is a get get array get array get, and here we will do, there is an insert or update a position or something like that. I think just look at the array. Can create, initialize, repeat from list, get, set. There is a set. Okay, append set. Okay, this is how this should work now that we have an array. This is array dot dot height, no, not height. What we need to do is we might need to do an array.get to get the arrow, because it's two-dimensional. Right, so we can say array.say, but first we have to do array.get. This will give us a maybe, so we have to do array.get at I, or no, the current row of the manifold case of and then okay, so let's just row will be, this will give us array dot set on the row, set the cell. If it's nothing, we return the same manifold. Otherwise, we array dot set the new row, and this is the new the on the correct column. I think this is parenthesized. This should be. Okay, and then okay, uh mm, drop drop there is a slice get subsection of the an array, start end. Okay, start end. Each row. Okay. Array that exists. How can we check that it exists? There is no there. It's very simple. It's like very dumbed down. Do we have to like map over it? I guess we have to do filter. How is this gonna work? It's gonna work. How many times that having the is valid gets called multiple times, so that should be an array. Or is there an array extras elm package? There is an array extra. Okay, nice. Thank you, Elm community. I saved me one second. Okay, so let's use those instead. Elm install. Say array dot extra dot slice from, and then array dot extra dot all, and then member array dot extra dot member array dot extra dot slice from all, and I guess array extra. Do they have a count? No, they don't. No, they don't have a count. So do we can say array dot filter given the current row, and then you can do something like this, array dot length So we filter the tachyon beams, and then we check that the length is less than or equal to 1. This is array, I guess extra indexed map, or is the map already? Let's see this. So I saw one like that. There is to indexed list, indexed map. There is an indexed map. So array dot indexed map. There's a row, and then here it's another array dot indexed map, and then it's an array dot concat, I guess. There's no concat. Is there a concat? No. I guess is there a flat join append? There is an append, but it appends two lists together. There is a push where it also at the end. So I think we need to do a Is there a fold? There is a fold. Array dot fold left, and then array dot append, and then our starting condition will be an empty array dot empty, array dot fold left, which is dot, and maybe this should also be returning an array, but no, this doesn't really matter. We're returning at most 3 elements concatenated together, and then we're counting them, so filter is valid. Actually, how is this working still? Okay. Yeah, so no, I don't know. I think we're at least using arrays for the process sale. It's not gonna help. It's not gonna do anything. Italian source part 2. Elm reactor part 2. Should we do some? Should we debug log to determine how fast it's going? Process cell should be going faster now because we're using an array. Yeah, reality check. We need to do it. It's already 4 and 30 parts. So it's crazy. It's already too much. We've already spent way too much time. But we are stuck at the worst position possible, at the worst situation that you could end up in. So if we know that we have a working algorithm, but that algorithm is too slow. Too slow. Way too slow. Is there think of ways we can make the go faster. Okay, you can number of valid ways to go from row column down to the last row, and then answer will be the start column or just dp if you need. Next positions, to implement that, define a function that given where the current is tells you all the possible row column positions it can be in the next step according to your rules. Might have a point. So it's like, given this, we should just we're creating a whole manifold object for each move we're making, for each placement or for each movement of the tachyon beam. That is wrong. We just look at the tachyon beams, and then if below them there is a splitter, then how do we represent that thing? How do we represent that they should go to the left or to the right? Currently we're creating a list of 2 elements, one that goes to the left, one that goes to the right, but that contains a copy of the manifold Um, okay, so we guys, so one of them went to the left, one of them went to the right. And then how do we know the current state of the manifold in the next call if we're just storing the position of the last manifold we added? What if we know, but if we only store the position of the manifold, so let's say process cell returns the positions of the manifold instead of the whole the whole grid, right? And then in each process grid call we can apply the list of tachyons it gave us to create a new grid, and then we can call it again with that grid, so it's like hydrating kind of situation. So here we would return, so here it will return the row plus 1 plus column, and then here when we add something to the left we would just say there is now a tachyon to the left of it, and then so here we get all of those values, we call them tachyon positions, and then how can we reduce them? We still need to be creating the manifold object one way or another. I think we would need to be creating the manifold object, but at least this way we're doing it for each ray and not for every character. Shit. This dynamic program method is talking about, I think you can do it greedy. Yeah, we have a working no, the it works for for the for the example. So he for 4 ማግኘት እንችላለን ግን the final output is taking way too much time to compute. Our approach is really slow. We're processing each cell, looking at each cell and building up a list of the new manifolds. Like we're really creating many worlds. Like let's say follow the many worlds interpretation of quantum physics. So we're copying the whole manifold, but we're not. That's not how we solve it. How long have we been streaming? It's been 4 hours. Yeah. I think we can just post repositions, store repositions. Okay. And then it monitor. It's like we're using all of my memory. I think, yeah, we're what the Elm server is taking holding on to more memory than. Yeah, this is taking all of the CPU time. About memory. This is what this is. Can't even brute source, but you're aware of this. In here, let's return an array instead. That's like we're returning at most four elements, but for each cell it adds up. It's not done. I don't know. I want to add up. Let's reduce the number of. No, we can't do that. I was gonna say let's reduce the number of cells we're gonna look at, but we should be looking at dots because there might be a tachyon splitter or a tachyon beam above them, so we don't know. Is there another place where we can use an array instead? Fuck. This is horrible. I thought we had it when we got 40 at them. I didn't know it was gonna be like this. I knew it was gonna be like this. I think I'm gonna remove this caching bullshit. It's not doing anything. It's not gonna help us. Just remove it. It's creating noise. Just creating noise all over the place. Remove cache stuff. We're copying the manifold for each. What's wrong? Okay, let me just. That's why this was returning a maybe. Shouldn't do that then. Just. Is that what it is? Oh, we added a bug. Wait a minute, what did we do? I think we added a bug in this thing. Why were we returning a list of maybes? I don't even remember. What? Shit. Can debug.log. Manifold. What? Oh no, this is why you should be committing at each stage. I think I introduced a bug. Okay. So for this, we generate this 3. Oh no, we were. Oh. Why isn't unique catching those? Unique doesn't work on arrays. Frippiani. Ah, shit. Okay. Think we can. Arrays are not equal to each other. The arrays are not equal to each other. Right. We should be removing this one. Or we should be removing this. No, but it did get removed. So in the other code, where did it decided to add it there? Okay, let's go back. I guess hopefully undoing will bring us back to what we had previously. Oh, I guess it's not using the example anymore. Example. Okay. Okay. Let me just save this so that we don't lose our changes again. I've reverted back to where we had it working with the example, and performance work is not gonna solve that. We need to, I think, rethink the whole thing. Rethink how we're solving it. Yeah, fuck it. Save. Okay. I'm just gonna commit this. Commit impairment day 2 part to working with example. Just gonna copy the whole thing, and I'm gonna try this one more time. If this works, it worked, but if it didn't, I don't care. I think I'm gonna end it. Maybe this is one of those days where we will do the first day where we're not gonna be able to solve both of them. Maybe I'll solve it sometime later, but I'm gonna ask the LLM to optimize this the process. I guess wait a minute, this is noise. This is noise. It's not gonna need that. Just manifold. Process manifold, and then let's go back, reload. Now I guess you have to just keep formatting. It tries to format it when you end. That's why it gets stuck. Maybe elm format part 2. Yes. And then let's do this. Commit. I guess git commit amend and then push force it. I think it's done. Okay, so let's do this. Let's go in here again, copy this, and that's the LLM. Okay, so optimize the function uh, we shouldn't be creating a new manifold object for each call to process sale. Or fix that. Don't, I guess, preserve the logic, but add changes that will make it faster. Yeah, it's not gonna work though. I don't think it has enough information to make it work. So አራት ሰዓት ምናምን ነው የተነሳው ከእንቅልፌ I guess. So we've been working on this for 4 hours. Yeah, we've been working on this for more than 4 hours. It's near 5 hours. Okay, let's see if the LLM will save us. Let's see who has finished it actually. Let's go to the leaderboard view. Okay, Aditya Singha, okay, and anonymous user David Mangastin. Yeah. State processor, just what kind of child it wants. Same or placement, type joint placement, type placement, save processor. I guess make it easier for me to get. You give me let me a new file. Let's see what it did actually. Here's one way to speed it up. It's not creating process. Okay, it's for apply placement and then change process sale to produce childs instead of manifolds. New signature class implementation. It's creating a new manifold object here, but okay. We'll need to run this on the example first. Let's run this on the example if it works on the example. So it does work on the example. Does it work on the input though? Input, save, reload. Nope, it's not gonna work for the input. Let's look at this. So instead it creates a children and then it's still creating a manifolds objects again, but it's not doing it for each sale at least. How is it using the dictionary? Oh, did the code we gave it have the sale cache? Actually, let me git restore cache. Oh, it was using the cache. But this one, okay, let's wait for the one, but let me copy this. I think it's gonna work and paste that. And okay, this one still works. Just make it use arrays instead. What the array kernels? No, it didn't work. It did not work. Let's think of ways we can. Day 7. This way we can follow the beam. Without modifying the manifold at all. Without creating a new manifold object, we can still do this. For each is the count. So if we had a function that would return the new code, and then this will be like plus plus, and it will only produce the position. So it will be the same manifold. We'll look at the same manifold. Just check. This is horrible. I guess I completely do the algorithm. We can follow the different positions. We can follow the position. The pipe should go to without actually placing them there. I think that algorithm will be, instead of, so we will it will not be a looping thing, it will be a recursive function. It will start at the middle of the second row. I think that's where all of them start. We will just remove the first row, like drop the first row, and then so the new algorithm will be something like this. So, and then we place one at the top, and then so it will be a recursive function. To get, how does it know when where it should split? It will loop over the manifold. It does not modify anything, but it will loop over it. It knows, and so the inputs are process, and then the current tachyon ray position, it will be an I, j, and then the manifold, and then so it starts from there. It starts iterating from I plus 1, in the rows below it starts looking at those. Right, then it will, no, it shouldn't do that. It should, no, it shouldn't even look at in the rows. It should know if it shows what I comma j in the manifold. It should immediately see what's I plus, like below it. Check what's below it. If it's a tachyon, if it's a splitter, it will call process like the main function, the same function we're in, the recursively called stuff, and then but it will now have the position y plus 1 or y minus 1, and then I guess no, j minus 1 and y plus 1. I will basically just do that, make two calls, and then I don't really know what this function returns. Alright, what is this function gonna return though? What does the process function return? The final position? So it will return the final, it will return a process, comma I comma j, and then manifold, and then it will just return a single int, its end position, because we're not keeping track of anything else. I'm gonna this is making my, this is stress testing my PC. I'm gonna make it stop, because I don't think that's gonna really do a thing. Did it follow that pattern? Let's go up here. You're using the example, localhost 8000 parts 2. Yeah, it's like this is wrong. I'm gonna git restore, and we're gonna do this. So let me just think through it. So I think that's the solution we should be using. So yeah, so it does I plus j, and then let's see. Okay, so what's the other case? If it found one, if it found a splitter, if it found a dot, it will not do anything, right? You know, it will call itself again. It will call process again with I, so the I plus 1 comma j. And then how do we, all of these are returning I comma j's, and then okay, so the previous one we will concatenate them, so it will, both of them will return a list. So the base case, so these are three cases. It finds a tachyon being below it, it finds a dot or an empty space below it, or it finds nothing below it because we're at the end of the list. In that case, it returns the current position. The current position I comma j. Then are there any rays that don't end at the bottom? No, all of them end at the bottom. I think it's literally impossible. I think that's like, I think I just thought of a new algorithm, but it will make us lose the, we're not gonna have the visualization. Let's save this, reload. So this one is visualizing each step because we're doing each step. I'm just storing it and visualizing it, but the new one will not have it. So let's remove those view functions. So let's just remove those. We're not gonna view any manifolds. It's not gonna okay, it's just gonna be that, and process manifold will return a list of int comma int, right? Delete all of this. So what we're gonna do is the first thing is we need to modify that toList function, or we need to add a place no, right? So for both of them we will place a tachyon beam right below. So think here in this input process function, we're gonna save it. It's not gonna format. It's not formatting, not cooperating. So after converting to a list, so we're gonna say, should we do it here, or so I don't know, let's call this prepare. I think we should just do it here. So after doing that, it's gonna do this late manifold, manifold, and then it's going to call it a manifold. Should have returned b equals, to have returned a manifold. See, why didn't this work? Because we have other errors. So now let's push them in. What? Okay, doesn't like to be formatted. Okay, let's look at other errors. So oh, it's because of this. It's not formatted because of that. Okay, then yeah, okay, so process for now just return an empty. So, and then let's go down here to list. I'm just gonna remove the first. So let's get let's say take or drop one. Let's drop the first row. We don't care about it at all. And in the second row, in the middle of the second row, I think it's in the middle, right? So let's count 1, 2. So this is 1, 2, 3, 4, 5, 6, 7, 8, 7. Okay, 1, and this will be, I think. Let's see. I think it's in the exact middle, if I'm not mistaken. Come on, let me copy a single line. And then just say that length 15. So there are 7 to the left and 7 to the right. You can just say split by 5. No, extra things. Yeah, okay, so it's exactly in the middle, so we can say middle is gonna be manifold list head, or I guess head, where this will return something. Or I guess this is width. Let's see width. the width. And then how are we at it? So we're gonna say new height is gonna be manifold. Maybe, or I guess we can do it here since we're gonna be iterating over the list. Let's do it here. Say let width. This is gonna be a new head. Gonna be width equals that in and list dot index map ix if I equals width over 2, I guess width minus 1 over 2, then tachyon, otherwise it's ax else x, and then maybe we could find that up here and no, and then this will be over r, and then maybe we'll default of this, and then this will be new head const on to the drop one manifold. I think it's a div. What does div do? Okay, let's see what this looks like to get just a feel that we're going down the right route. Let's underscore request debug the load manifold, not manifold, yeah. So where is the okay, I don't see it. It should have been added to the top of the list here, but I don't see it. Okay, why didn't it get added? So this condition never became true. I'm gonna say debug log middle. This condition never ended up resolving to true. Telling me false. What is this then? So it's gonna, this is the width of the current row, which is 15. 15 minus, I guess, let's see what this looks like. They don't want to script. Maybe this is returning a float. Oh no, it's not happening. This is not I, but middle. Middle is 15. Oh, I guess precedence. Okay, operator precedence, I think. So we need this to be computed first. Yeah, it's an issue with operator precedence. Okay, so let's bring the middle here, middle, and then do this. We can bring it in that, and then we can remove that and say if I equals middle, and then of course just remove that. Okay, now we have the start position. Okay, now that we have the start position, what I'm thinking of doing is keep this manifold logging here. It will help us. So it will return a list of all the final positions. Yeah, it will return a list of all the final positions. This will be recursive. We'll need one function. We'll need a sale at function. Specifically, the only check we're doing is sale below function, I think. So it will always be. Let's go here. We will not need you. Actually, let's remove this whole process sale function. We're not gonna need it. We're rethinking the whole thing, the whole solution. It's like this is like the third time that we had to rethink the whole solution after the example. The third or fourth time, and then this will be. This is what should like. This is what it should be. This is that, and then this is this. This is that. This is this. Perfect. And then I don't think we will need these two. Have ended is valid. Bullshit, we don't need those. So okay, so what we're gonna do is I'm gonna say actually just do a sale below equals get a row column. We can do sale at row +1 and column, then we can, the types can be inferred. It's gonna be int. So sale below is row +1, so we're gonna say we're gonna begin. We're actually gonna need to be called with some with some starting condition, right? We're gonna need to be called with some starting position, that is an int, comma int, and this, and then let's say row, comma column, and I guess we need to list. It's gonna need to return 7 somehow. How do we know 7? How do we extract 7 out of this? So it's gonna be something like this. So it's gonna be middle and then comma and then middle, comma, the new head. And then this will be 0, comma, okay, so now this toList function will no longer just be, it will also return the starting position, which is int, comma, int, comma, manifold, and this is what we will return here. It will be 0, comma, middle, comma, no, and then this is parenthesized. So let's go back here and say process manifold, position, and manifold. Okay, let's go down here. Shadowing, okay. And call this new middle then. New middle. Okay, this is what the thing is gonna be called with. So we can say case case cell below of row, comma, column of, and then let's so there are a lot of cases we'll need to look into. If the cell below is if the cell below us is A, the first thing, the simplest case is it's a dot. So we'll just continue. So we're gonna return, okay, in that case you are going to return a process manifold of the current row, comma, no, the current row, comma, column, and then just row plus 1. So just go down, let's go down and check if there's anything there. That's the first case. Oh, okay, I guess, yeah, so this is, we will need to pass in the manifold here. Okay, not all branches are covered. Okay, yes, that's correct. We're still working on it. So okay, if okay, more like the splitting case, so something below us is the splitter. So what we need to do is process something the left side, which is gonna be column -1 plus process manifold of the row plus 1 and followed by column plus 1, so right next to it, but this is not working for some reason. And then the final case is these are only the two kinds of numbers we will find. Oh no, what the fuck am I even saying? We don't actually need to place anything. I'm thinking in a stupid way till let's count. To do is, okay, we don't actually need to place it. So what we just need is with this just the middle. This is what we need. Right? Then this is gonna be we don't need this at all. Middle and manifold. So okay, let's go back here. The base case is we found an unknown character which will never happen, or we didn't get anything. There's nothing below us. So in that case, we will return row, comma, column. This is the case. This is how you do it. This is that. This is this. Why do they keep? Oh, I know. I get manifold. Okay, I think this is it. I think this might be it. I guess okay. In that case, it should be 0, comma, middle. Let's remove this, remove that, remove this, remove that, remove this. We're still using the example, and then see. Nice. And then since the manifold doesn't change, so our example is correct. So since the manifold doesn't change, and then let's run this on the example. On the input, I mean. It still takes way too much. This is our second implementation. We rewrote the whole thing and it's still taking a while. But I think in this case there is a lot more we can cache. I think. Right? Maybe somebody's already saying it in the comments. Okay, no, nobody's saying it in the comments. But I think this one is easier to cache than the one we had. Okay. I guess the recursion, we're doing a lot of recursion. Rewrote the solution to look like this. What optimizations should I apply because it is still too slow? Well, handing out solution is much more simpler than the previous one. I think maybe since we're using an array, indexing into the array to know what's below us takes a while, but I think we can maybe use an array instead. Yeah, using arrays instead of lists would maybe help pre-computing positions and detecting. Good catch. So instead of doing that, okay, this is actually correct. Let's just count. So there is 1, and this will return an int, because since we're not gonna be doing any visualizations or anything, we can just count, and then this will be just normal addition. Example. Okay, that's a good optimization. because we don't need a list actually. I was thinking we might need to know. Yeah, with that it's still slow. Memorize have problems. Okay, I guess let's do give me the memoized version of this. It's still taking way too much time, but I'm more comfortable waiting for this than the other one because this one is way simpler than the previous one. But the memorization doesn't seem to be working. But even though we're following this direction, that's still way too many. It's way too many words. Way too many words. Way too many words. Way too many words. What other optimization does? It is still way too slow. Linear time is also too much for us. We need logarithmic time. I don't think the memoization is helping, to be honest. Process. Oh no, we're not using its function, its new function. Should be using process instead. Did we copy this correctly? Got an A. We weren't using the memoization example. Ah! 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 Ah, shit. Mm. Ah, fuck you, Advent of God. God damn it. Ah, uh, okay, we did it. We did it. It's done. But we didn't actually do it. We came up with the algorithm, but I guess the memoization. I just was too tired. It's basically just storing the position, the new count based on the intent row, so that we don't do the subdivisions again. We can reuse. If you're gonna go down these rows, don't bother. It's already been counted by another call to this function. So I was just too tired of implementing this dictionary based memoization. Actually, we implemented it twice before for the previous solution, but I guess this, yeah, I gotta think more like this, like. Uh, Maybe it's because I was using a browser like language. I wanted to visualize it. That's why I wanted to return the final manifold. But yeah, you gotta think about your type signatures way more. So it took us more than 6 hours. Yeah, finally, but it's crazy. It's crazy. I'm done. I'm actually seriously thinking of quitting. I'm not gonna do anymore. I'm too tired. But maybe I'll feel better tomorrow. Let's see. Holy shit. Uh, get out of my face. Push. Let's go back to the README. And yeah, today's memes on Reddit are gonna be good. Let's say day 7 implemented in Elm, and let's go to the Elm website, copy the URL, and commit your update README, push it up. Let's go to Reddit and see a couple of memes. I guess Advent of Code, and let's look at the leaderboard. Let's close these Elm documentation pages, and we don't need them. Why? This was beautiful code. It was me when I accidentally destroyed the wave function because I want I want to look at the tachyon. Assembly? Oh, day 3, okay. Cloud Sunny reading the story about disabling global leaderboard, a good move, yeah. Oof, okay, that's a good visualization. Beautiful. Day 7 part 2 sounds like an Excel pro. They did it in Excel? Whoa. And this was the function? What? That's crazy. I may be late for the fan, but I've made my okay, I guess day 2. Not sure if I'm debugging the tachyon manifold or decorating a Christmas tree. Yep, but we were part 1. We were decorating a Christmas tree when we were in part 1, but part 2 got, like, we went quantum. Advent of God of Bionet. Yeah, it's good. I've looked across millions of realities. And how many does the particle touch the memory? Okay, and let's look at this. Yeah, so I don't know where we're gonna be going, but yeah, the tachyon manifold. I think maybe 1, 2, 3, 4. I'm the 5th% to finish. I think 1, 2, 3, 4, or the 6%. ስድስተኛ ወይ ሰባተኛ ሰው ነኝ ስጨርስ። So yeah, so this has been, let's go back to the github/fractone/advent of code. Yeah. Oh no. Oh, HTML 77%. I know what went wrong, what we did. We accidentally included the compiled HTML generated. Yeah, let's remove that. So let's go into, I was gonna say our graph is looking beautiful, but apparently no, not day 6, day Parts. Oh no, what the heck, day 7. And let's remove the index. Where was it? Dash 3. This is it. Some parts. 2. Index.html. Remove Elm compile output. Push. Okay, now this graph is looking more beautiful. We have Elm, Haskell, Idris, OCaml, Gleam, Rest, and since it doesn't know about Unison, it's listed as other here. But yeah, so we've used seven functional programming till now, and yeah, Rust is a functional programming language in my book. But yeah, so maybe we'll find another good functional programming language we can use tomorrow. Otherwise, I'm thinking maybe TypeScript or Go or something like that. Yeah, maybe we might need, I think we might have run out of functional programming languages to use. I don't think there are any more other cool ones out there. Maybe we can try Rock tomorrow, the Rock programming language. But I don't know where they have the compiler, or I don't think it's supported in my editor. Helix has Rock. Yeah, Rock is not even known. Yeah, this might be hard. I don't know if I'm gonna use Rock. Yeah, so yeah, goodbye everyone. Yeah, good job. Good job on Soul Singham. And memes on day 3 or 4 was crazy. Elixir. Oh, Elixir is good. We might do Elixir, but I like types way too much. But at least it's functional, so I think we'll do Elixir. Yeah, so that's a good suggestion. We'll do Elixir. Goodbye. And no, we're not gonna use Go.